Well, you can be a little edgy and say, son of a motherless goat. That's kind of edgy.
Wait, for test corrections, can I just fix the end, or do you want me to have to rewrite the whole problem?
You have to do it with Kramer's rule.
Oh, yeah.
I tell people I don't like num-nums.
You don't like num-nums.
No, I call people that I don't like num-nums.
Oh, there you go. I heard this guy tell a joke. It was a story joke, so I'm not going to tell the whole thing. But basically, the gist was he went into Whole Foods and he kept hearing people say namaste, but they were all really rude. And so he decided probably a namaste meant to heck with you. And so this lady was rude to him in the parking lot, and he said namaste.
That's great.
It was quite funny. Anyway, it's better if you actually tell it out, but I don't have time for that because math. So, what questions from the test?
Everything.
What did I do wrong for the number one, even though I technically didn't do it for Kramer's rule? Actually, screw that. Can we just do number one of Kramer's rule?
I'm tempted to say no and make you just use your notes with that, but I will at least get us start the beginning of number one, and then you can use your notes and whatever else to finish it. So, what method is Kramer's rule? Finding determinants. So you got to find the determinant, you got to find the determinant, and you got to find the determinant x, and the determinant y, and the determinant z, right? We remember this kind of where we do the big determinants, yes? Big determinants, other big determinants. To do the first one, you just write all the coefficients, right? So it's 2, 1, negative 1, 1, negative 3, 2, 3, 2, negative 1. And to do the x one, you just replace the x column with the ones that are by themselves. So the x column would be 1, negative 2, 3, and then everything else remains the same. Okay, so and then you do that for the y one and for the z one as well, right? To find the determinant of a 3 by 3 matrix, at least using the method that we learned in this class, there's the other method where we do a bunch of diagonals and all that stuff. You do this number times this determinant, right? So 2 times the determinant of negative 3, 2, 2, negative 1. And then we change the sign in the middle, so we subtract. So subtract this one times this determinant without this middle one, so these ones. So minus 1 times the determinant of 1, 2, 3, negative 1. And then you add the last one, so this one times this determinant, right? So plus negative 1 times 1, negative 3, 3, 2. And you have to, in order to do those determinants, and to do the multiplication, you have to do the determinant first and then multiply second, right? Okay, so you can't distribute this 2 in there and do all that. To find the discriminant, not discriminant, totally different word, totally different context, totally different thing. To find the determinant of 2 by 2 matrix, you do the down diagonal multiplied. So negative 3 times negative 1 is 3. Minus the up diagonal multiplied. So minus 2 times 2 is 4. So 2 times negative 1 minus 1 times negative 1 minus 6 minus 1 times 2 minus negative 9. And then you keep on going until you get a number, right? And then the punchline at the very end is the solution to the system will be dx over d and dy over d and dz over d. So it's that method, yes?
Yes, I didn't quite catch this thing. When you have them in the determinant box, you do negative 3 times negative 1 and then,
You're talking about which one? This one, this one, this one.
All three of them.
So the down diagonal, which is this, minus the up diagonal.
Multiply.
Yes.
Okay.
Yes. And that's Kramer's rule. You have notes of all of it and all the things too.
That's just 3.
All right, what other questions, childrens?
Oh, on 8, is it the A plus AX plus C? Is that what it is?
On 8, it would be the a over x minus 1 plus bx plus c over x squared plus 1.
Correct.
Okay. Can we do 4?
Can we do 4? Is that the one of the inverse ones? Yeah, sure.
Yeah.
That was the last unit. Oh, you mean SIG in science. I see. I made coffee. I should drink it while it's hot. And then we'll come back and do 4. Do your test corrections. Okay, numero 4. We're supposed to solve 3x plus 2y equals 7 and x minus y equals 1 using inverses. So, step 1 is finding the determinant of the coefficient matrix, because we're going to need that in a minute to do the inverses. So find the determinant of the matrix 3, 2, 1, negative 1. To find the determinant of 2 by 2 matrix, we just remembered we do the down diagonal minus the up diagonal, multiplied both cases. So negative 5. Then, to find the inverse, we multiply 1 over that determinant times the matrix, where we swap the down diagonal and swap the signs of the up diagonal.
Oh, yes.
So that equals positive 1/5, positive 2/5, positive 1/5, negative 3/5. All right? Then what do? Do we remember?
Multiply it times 1 or 7 and 1.
Multiply that times the result matrix. That's right. So times 7, 1. And when we multiply matrices, we do row by column and add. So 1/5 times 7 is 7/5. 2/5 times 1 is 2/5, so plus 2/5. 1/5 times 7 is still 7/5. Negative 3/5 times 1 is negative 3/5. So we end up with the matrix equation, x, y, equals 9/5, 4/5. And we could circle that and move on, or we could write it as an ordered pair. I would accept either on a problem like this.
I forget that.
Can we do 6?
Yeah. I didn't mean to make, and I didn't notice until I was making the key that I made the denominators the same on 6 and 7, but I decided that was probably fine. I made the problems 6 through 8 using Grok, which was awesome. This is the first time that I've used AI to make problems in a while. I've tried it with ChatGPT a long time ago. I tried it with Gemini before it was Gemini, back when it was Bard, and both of them were kind of awful. You had to like type in a whole bunch of stuff to get it to do whatever, and it ended up having repeated problems, and it was just stupid. This, I was able to say, make a this thing or whatever else, and then I was able to say, okay, do it, and make it to where the answers have bx plus c, whatever, in them. And it knew what I was talking about. It was flipping amazing.
Nice.
Like, wow, that's awesome. All right, we're 6 is what the one you asked?
What did I do wrong?
We're about to find out. That would be annoying. All right, what do we got to do to find the partial fraction decomposition of this thing? You have to do blobs. We got to factor it. Wow. Yes.
Oh, wow. Alright.
Right? Right. Now what? We kill the fractions. Then we get the x's together. And the not x's together. Then we've got that one equals these one, and that one equals that one, and we solve that system. We shove it back in there, and Bob's your uncle.
What is B equal?
B equals 1 in this particular problem. Wait, what are we doing?
Well, like
Oh,
before you stick it in.
yeah, so by the way, since we're doing corrections, what you're going to end up getting, what are you saying?
When you solve it, what does B come out to?
1. No, 1/3. Yeah, so you're going to get 8/3 and 1/3. On the test, if you wrote 8/3 over x minus 2 plus 1/3 over x plus 1, I would not count off. On the corrections, we need to clean that up because we need perfectly correct on corrections. So how do I clean that up?
You multiply the bottom times the two denominators together. Or
No, because that's just going to put it back to that.
no, rationalize it, is what I meant.
It's not really rationalizing.
Moving 3 to the bottom.
Yeah, it's just going to be 8 over 3 times x minus 2 plus 1 over 3 times x plus 1. Yeah? Right?
Do you distribute that?
No, you wouldn't.
Why is that a better answer than the other one?
Because this one's a compound fraction. Compound fractions are ugly. I'm really curious how this scammer is going to try to scam me at this point because she's already claimed that she lost 2,000 euros to a scammer. What? I keep thinking this is going to be a romance scam, but it keeps going weird. I don't know. I don't quite understand what's happening. It's clearly a scam. I'm pretty sure I've been attempted to be scammed by the same picture person before, but you know, whatever.
I keep getting job offers in Toll Road.
I have gotten a bunch of job offer things. Those are funny.
The guy who had my phone number before me was an absolute idiot with his data, so I now know his full legal name.
Well, there you go. Well, full legal name is small potatoes. If you know his name and date of birth and all those
I
things.
do have his date of birth.
Do you really?
He
Oh,
didn't
no.
tell his friend that he had a new phone number, so his friend texted me on his birthday.
Oh no.
I literally have a whole document of just stuff that I've learned about this.
Did he say how old he, like happy 25th? Because then you'd have even the birth year.
I think I figured that out from somewhere else, actually.
That's hilarious.
My guy's name is Shannon Duke Roy.
Shannon Duke-Roy. Shannon Duke-Roy. Okay.
Jason or something.
No, that's his full name. Shannon, middle name Duke.
Yeah, I know. I was being silly. I followed you.
Duke Roy is actually kind of a cool name.
Yeah, that would be pretty cool.
Or Schneider.
Schneider.
Are we doing a unit, whatever?
Yeah, we're
I
gonna.
did get his date of birth, like year something out. March 10th, 1981.
There you go.
His birthday was early this year.
He's older than me.
Oh yeah, because I got his email, J.R. Schneider, 1981 at
Oh, nice. That's funny. Oh, there you go. You should send him an email. You should try to scam him. He's clearly gullible.
Send an email with all the information on it. That'd be funny.
just put all his information and make a burner email, some Gmail or whatever, and send it and all you put is in the body put his information, and then the subject put "dis you?" question mark. That would be funny. And be like, what? What is happening? All right. Are y'all ready to turn your graphing knowledge sideways?
No, I don't like him.
I think we've done that.
You have,
Yeah.
in Algebra 2. We covered some of this unit, not the pre-calculus version, but we covered some of this unit at the end of last year in Algebra 2.
Oh, are we doing the circles and stuff?
Yeah. And today we're doing parabolas. I know.
Unit 8? 7.
Unit 7. We are covering a unit on conic sections. So we're going to start with that. We get to draw a pretty picture in our notes. Are you ready? We're going to draw conics. I'm even going to use a straight edge. I'm going to make it cool looking. Of course, I don't have a very long straight edge anymore, so, YOLO.
Parabolas.
Yeah, it is pronounced parabolas, but
Oh yeah, it's like the hourglass stuff.
yeah. This entire unit is learning about the different kinds of shapes you can make if you take this thing and you slice it. Okay? So, we can, if we slice it like this, we get a parabola, which is what today's is about. This shape. If you want to see a better picture, you can look at page 422. Because I'm not going to take the time to draw it better today. Although I could, but I'm not going to. Peace, homie.
Oh, there's two.
Okay.
Drew one edge.
So, the form we have seen of a parabola before today is something like this, right? F of x equals ax minus h squared plus, actually, bx plus k, right? We've seen this before. We've seen the vertex equation for a parabola before. That's great. This unit, we're throwing it out the window, throwing it in the garbage using a different equation, actually 4 different equations. Because now, not only can we have parabolas that are functions of x, we can have parabolas that are functions of y. In other words, we can have this parabola, and the sideways ones. And we can have that in lots of fun. And if we have 2 parabolas, then we end up with in the next lesson, we end up with hyperbolas. Where's my eraser? Would you hand me that, please? Careful, you'll get dry erase marker on your hand from it. Yes, if that isn't the epitome of hyperbole, which I would argue is not Brian Regan's best comedy special, but it is pretty funny. I like his older one better. All right, here is the 2 standard forms of a parabola. x minus h squared equals 4p times y minus k quantity squared. This is for a vertical parabola. So our good old standbys, the ones we've seen before. So it has a few special characteristics. It opens vertically, which I just said. It has a vertex at HK. And it has a focus. Does anybody remember from last year what the focus means? Probably not.
No, at the center or something?
Kind of. It doesn't really have a center because it's infinite, but it's related to the center. It is the point. It is a very important point. This particular way of thinking is actually gets us a different context for real life parabolas. So historically, when we talk about parabolas and we talked about real life, we've done word problems. We've done one of two things. We've shot missiles and we've launched basketballs, right?
Yeah.
And we've done something like that, right? That's what we've done. But now we are doing something where we can use parabolas that are 3D. We're not going to really learn about that. But this math carries over when you get to that in either linear algebra or calculus 3. What is a parabola that's 3D?
A bowl?
So, kind of. No, it's not a sphere.
It's like a vase that goes on for...
It's like a satellite dish. A satellite dish is a parabola. And that is exactly where we would see that, because the focus is, if you're going around the bottom, where we hit, going here, let's go back to our 2D shape. The focus, somewhere about like that on this parabola, is wherever we would hit the same place as we were going around. So if you are aligning if you are designing a satellite dish, what does a satellite dish do? What? Make things go poof. Well, it usually receives signals, actually, but some of them do both. There is a transmitter. But so it's not very common anymore, so y'all probably barely know what I'm talking about. If I have satellite television at my house, what do I have on my roof or on a pole in my backyard?
That thing.
I have that thing with an arm coming off of it. What do it do? What do the dish do?
It directs all the signals to one point.
So, well, yeah, okay, you're stealing the punchline. What does it do? Like big picture, what do it do? What is it called? What kind of dish?
Satellite dish?
Satellite dish. Where is it getting signals from? Satellite's going. This is taking signals. Why does it have a dish and not just an antenna?
To give more signal.
In case the satellite misses. And if it misses, then it hits the focus.
Perfect.
That's what the focus is. The focus is the focus of the parabola. It's where it's focused. Hence the name focus. Wow. And to find the focus, this is the formula that we do. H, which makes sense because it's going to be dead center, right? And then K, yeah, that's right. I was right. K plus P. Okay.
The vertex is easier to get on these ones than it is with the old.
Vertex over here is just HK as well. So, boom. Now, you're probably thinking of like the vertex formula, which would be what you would use if you were given the parabola in standard form, where it's like in descending order and all that stuff. But if it's in vertex form, it's just as easy. Okay. The directrix, which is not a math variable that likes to wear leather. I know it's a stupid joke, but works. Okay. The directrix can be thought of as like the anti-focus. It's the other end. Okay. The directrix is found at h and k minus p.
Why is it called directrix?
I have no idea.
Because like the trix suffix, that means female of something.
Right?
Like gladiatrix.
It's probably that it's probably opposite in this context. It's probably kind of where it's going from, but then I don't know what the direct is. Yeah, I know. So the folktrix is, I don't know, whatever. I have no idea what the real life connection with a directrix is on a parabola. I know one use for it on like an ellipse or circles or whatever, but I have no idea. But that's how to find it. It's the anti-focus. Maybe alternate universe. I don't know. Where if you were trying to turn a parabola inside out, directrix. Right? Actually, a parabola turned inside out is a centroid, and it's pretty dang cool because actually, is my coffee cup empty?
Looks like a heart at the bottom of the cup.
Yep, that's what it is. It's a parabola turned inside out. It's really cool.
Have you ever looked at a cup?
All right, now the horizontal one looks like this. What do you think it's going to look like? What's your guess? Oh, this one's wrong. I don't know what I'm dreaming. This one's like definitely wrong. Yeah. This one is not even a parabola. What I wrote it's not even a parabola. What I wrote is like an ellipse or something. I don't know. What's wrong with it?
Square.
Yeah, one of the squared. Which one?
The left.
50-50 shot. You guessed wrong. You picked wrong. So the right. If it's opening up, the x is the one that's squared. So that shouldn't be there.
Is that it?
That's it. That's it.
That's it? Okay.
Yeah. Now, so what?
I was gonna guess how it changes with the horizontal.
Yeah, you were going to be able to guess, and now you're going to be able to guess even easier. See, I made that mistake on purpose, right? So smart. Look at me go. What is the horizontal one going to be?
The H and
Make the
K.
other one square.
Yeah. I don't know why I just put P. That's dumb. How about 4P? Excuse me. I don't know what I'm doing. I've been making mistakes all morning.
I don't know what you're doing either. If that helps.
I'm just writing the thing.
Why are there two K's? Where did the H go?
I don't know. I thought I was done making mistakes writing this equation. There we go. There we go. Now it's reasonable. So, how do you find the vertex from this one?
KH?
Is it?
Or is it negative HK? PK? There's only so many letters. I can guess eventually. HK.
H still goes with X, K still goes with Y. It's still going to be at HK. Now, the focus is going to be different, right? Because we're turned sideways. We're turned left or turned right, right? We're not up and down. We're open left or right. So, what is the focus going to be?
H plus P and K.
That's right. And what is the directrix?
The opposite of the thing on the road.
Minus P.
H minus P.
What is the P?
Oh, I'm an idiot. It is H minus P, but that's not even right. It's not the anti-focus. It's kind of the anti-focus, but it's not a point. I knew that. Silly goose. I stole your words. It's not a this.
What is the long?
At least I'm writing pencil for that.
What?
What is P?
It's a number that goes right there.
So it's just three.
Yeah.
Hey, what did you fix?
I took off the parentheses. And I also am going to take out this H. And I'm going to put this in here.
So the
Stressing me
directrix
out.
is now x equals.
Oh yeah.
Wait,
Okay.
So then the
Wait, I
directrix on the
gotta-
other one changes.
Yeah, the directrix on the other one. I also didn't write one thing, although it's an obvious thing, so y'all could probably figure it out without my help. But,
Well, at this point, I don't know what's real and what's fake.
well, that's fair enough. I don't know why I wrote it. What am I writing? What is happening? No, that's right. Okay, because this minus, yes. Yes? It's a great day to be alive. Yeah, no, that's right. Because this, yeah, down to, yeah, that's right.
So then what's
That's
the other
great.
thing that
This
you
is great.
apparently got wrong?
Axis, I didn't get it wrong. I just forgot to write the axis of symmetry. How would we find the axis of symmetry?
Axis of symmetry is just the vertex. It's just,
It's a line, just like the directrix is a line.
and it's where the vertex is.
Yeah, so,
It's the x.
well, it depends on whether we're opening up and down or whether we're opening left and right.
It's h on the vertical one and k on the horizontal one.
Yeah. So the axis of symmetry in this case would be what?
H. 0.
No, what am I writing? Good Lord. X equals, it's not 0, unless it is 0, and then it's 0.
I was doing it like the coordinates, so yeah, I was thinking.
Yeah, assuming that's centered at the origin. Where are you getting axes over here? Making it up. You're assuming that its vertex is 0, 0. It's rude. Shouldn't assume things. It's going to be x equals what?
K? No, H.
H.
So X always goes with H and Y.
Yes.
Okay.
Yes. So, oh my gosh. Y equals K. All right. So what actually is the directrix? Because I lied, kind of.
The lines.
It is a line. Where would it be?
The focus and the vertex between those two.
Mm-hmm. Which would be where?
Where the antenna would be.
No, the antenna would be right here, at the focus. That's still right. I said nothing wrong about the focus.
We should do an example.
Yeah, that's what we're doing next. Let's do this one. Actually, what time is it? Let's do that one instead. Better example. Get more things in one example.
My brain hurts.
Good. No, just kidding.
My thingy has connected somewhere else.
Yeah, you can graph these on what you're actually looking for almost certainly on your calculator to graph it is putting the graphing menu in relation mode instead of in function mode. And then you can almost certainly check your work and all the things. Now, these you're definitely going to have to show your work, the algebra parts. So we are going to write y equals -1/4 x squared plus 3x plus 6 in standard form and we're going to identify the vertex, the focus, the axis of symmetry, and the directrix, and graph it. Okay. I hope you have not completely and utterly forgotten how to complete the square, because we're going to have to do that. Now, so let's see if we remember some of our intuition about this. Is this a vertical or a horizontal parabola?
X is squared, so it's vertical.
So it's vertical, because the x is squared. That's correct. Is it opening up or is it opening down?
Down because it's negative?
Because a is negative. True enough. Because leading coefficient is negative. So this is going to be a parabola opening down. So we need to get this into standard form. So, how do we do that?
Remember what standard form is?
So we just wrote down the vertical equation.
Yeah,
In our equations.
you just said we'd have to complete the square, so I'm gonna guess that.
Yeah, we've done this before. In fact, I'm pretty sure we've done this in this class before for these kind. Let's do this. I gave you a hint.
Oh, yeah.
Gotta find the green part.
We're not there yet, but yes, that is a thing that we are going to do. So, what am I going to need to do now? What needs to be true before I can complete the square?
A has to be 1.
A has to be 1, that's true. How are we going to make A 1?
Multiply times 4.
No, we can't multiply it.
Divided by
Kind of. But we can't just start dividing stuff by 4, because then we got to do it on the other side.
Multiply everything.
Factor! Excuse me, we got to do some factoring. Right? Right?
Scared me.
Good.
I was ready to leave.
You ready to leave? I was about to jump up here. When I factor a negative 1/4 out of the first term, what do we have left?
X squared.
X squared. Now it's a little trickier. When I factor a negative 1/4 out of the second one, what do I have left? Negative, true. Negative what?
12.
It is negative 12. Because you're dividing 3 by 1/4. How do we divide fractions? Flip and multiply. 3 times 4 over 1 is 12.
Okay, so then we'll have 24.
Okay.
No, that one, we don't do that. That one is going to hang out outside the parentheses. But we can't just... Wait, we haven't done anything else. No, we can just. We're good so far. Right?
Yeah.
Nothing wrong with that. Factor a negative 1/4 out of the front. Slap it.
Why aren't you factoring it out of the 6?
Because we are not completing the square there. We're completing the square in the front part. He's going to be the K or something. Or he's going to be part of the K. Now what do we do?
Now we find the green part.
Now we find the green part. It's true enough.
Is that
How do we find the green part?
negative b over 2, or is that something?
That's something else, but you're in the right ballpark.
2b over something.
Yes.
Yes, we did.
Negative 2 over b.
Like unit 2-ish, I think. Thereabouts.
2.
B divided by 2 squared.
Ah.
I don't think I comprehend how to do this square.
Maybe. I don't know. Can't speak to that. Negative 12 divided by 2 squared. What's negative 12 divided by 2? Negative 6, of course. Negative 6 squared is positive 36. How we do it? Pretty good?
Doing great.
Now we do.
Do we add 36 into the...
We add 36,
Subtract it from the outside.
and then we'd have to subtract 36. We're not really subtracting 36.
We multiply it by the negative 1/4.
Yes, and that is what we're subtracting. So what is negative 1/4 times 36? I'll do this in the
9, negative 9.
So we're going to have to subtract negative 9 from the outside. So add 9, right? I'm going to even write it minus negative 9 just for complete and utter clarity. Because we added it here, and so we got to take it away over there. But because this was negative, it's flipping it around.
So you only do that if it's negative?
Yeah, if what we pulled out was negative.
If it was positive, you just
You'd still you'd still multiply it, but and you take away whatever that was. So this one is always going to be negative. This one will depend on what you took out.
But that's
The
what
9 is
Ow.
taken from multiplying what you took out times what you got.
Yes.
Always.
Yes.
Okay.
Yes. Now what?
We have positive 15 over there.
We do have positive 15 over
We're
there.
adding 9 on that side, right? On the. Wait.
Ultimately, yes, because we could chink over here, right? And so 6 plus 9, yes? Yeah. We do factor. What is it always going to factor into? Always, without fail. The thing in the middle. So it's always going to be x minus 6. Well, it's not always going to be x minus 6, but x plus or minus this squared. And then we've got the plus 15 over here. How we doing? We doing okay?
I'm a little confused on. So since the 1/4 is negative, we have to multiply it by the green part to get that over there. And why is that minus on the?
Because we added it. So, and so we had to keep balance. You have to either add it on both sides or add it and then take it away on the same side.
So 36 was negative and you would subtract it when you add it to the outside?
It will never be negative because it's squared. So we're not there yet. We're not in standard form. We are in vertex form, which is great and useful, but it's not what we want yet. What does this form look like? Let's jot it down up here so we have something. We know what we're going to. What does it look like?
X minus h squared equals 4p
Y minus k.
times y minus k.
Great.
The,
So we're not quite there yet. We're discombobulated.
X minus something squared.
That's true.
Nice.
It is. That is nice and true and all the things.
Y over on the left, which we want. Or on the side opposite from the x.
Right.
And then, so we'll move the other stuff over?
That's as easy as it is, yes.
And then multiply it all by -1.
Yes.
Okay, how glorious.
or multiplying all by -4 to get rid of that 4.
To get rid of the negative 1/4.
Oh, yes.
I almost put the squared back in the wrong place again. Now we're in standard form. He matches. Yay.
Oh, wait. Why minus?
Great. So let's start writing the things.
Oh, -1.
What's the p in that?
-1, right?
It would be -1.
And where did we get
I was about to, we're about to get there.
So you divide what you have in there by 4. What's left is p. Because they multiply together.
Let's write it here. Let's start with where we start. Vertex. What is the vertex?
HK. So that would be -6 and 15.
Great. Now, for the focus, we need to know what is P. We know that P is right there. And right there we have this.
Isn't that -6 and -15? No, because they're minus in the standard form, so then we have to
It's
take
the
it.
opposite side of, yeah. Okay. So, 4P lives here and this lives here. So 4P equals -4, right? In our problem. So P is -1, right?
So it's whatever.
Mm-hmm. Okay. So the focus in our problem be 6, 14, right?
Yeah.
What about the axis of symmetry?
I'm sorry, I was writing something. 614. Where did it come from?
Because H and then K minus 1. Or K minus, K plus P.
It'll be 6.
It will be X equals 6. It is extremely likely that in a pre-calculus class, if you wrote 6 and only 6, I'd count off a point. Because it's a line. No, I wasn't even griping. I was just telling you that that's a thing that would be likely to happen in a pre-calculus class. Not an algebra 2 class. Actually wouldn't, well, we would do this. Okay, so what about the directrix?
X minus 15, or X equals 15 minus -1.
X equals 6, or Y equals 16. That's also a line.
And that's from the equation.
I thought it was another method.
Okay, let's graph the thing.
Why is it y equals 16?
Because the equation is Y equals K minus P.
X equals k minus p.
Okay, let's graph the thing. We might just have enough time to do that problem, which would be really good, because if we get, yeah, that's perfect. Yeah. Oh, we're still missing one thing, and we're not going to get there today. And we definitely do want to cover that. Stupid pre-calculus and doing stupid stuff.
Where's that what? Y equals menu?
What?
XT1. YT.
Is there a reset button on your calculator?
There is. And if you're Googling how to do it, you want to Google how to clear the memory.
And now we just put it in our calculator, and then that's the answer.
We graph it.
Also, the calculator.
What do you mean that you put it? Why would you put it in the calculator? You did all this work. What's the point of that? I know, but what is the point of that? We just did all this work to like do all this stuff. Why would you wait? I mean, if you want to put it in there to like check your work, sure, but like we have all the puzzle pieces that we need, right? So why would we waste our time doing that? So we go over 2, 4, 6, up 2, 4, 6, 8. Did I write it backwards on the thing?
Whenever we wrote it down on our, whenever
Should be a Y equals, because it's a line, yeah, I don't know. It should be Y. 2, 4, 6, 8, 10, 12, 14, 16. So right here, and it's at here. We need like 1 point, right? Because if we get 1 point over here, we can get the same point over there and connect the dots, and we've got it, right? So what point do we want? How about 0? I like that idea. How about let's find where x equals 0. So put a 0 in right here. We've got -6.
So the axis.
Actually, I lied. No, just kidding. I was about to.
So that's where the middle is.
Yep.
Okay, and then the directrix. 16.
It's what the directrix is, actually. As I was realizing that it was a line, I realized what it actually is. The directrix is what, if you took the line that the directrix is and bent it around the focus, you'd have the parabola. That's what the directrix is. You don't really have to know that, but that's what it is.
So
Anyway, What am I doing? This. What's negative 6 squared? 36 divided by negative 4. So y minus 15 equals negative 9. Add 15 to both sides. We end up with y equals 6. No, because we add 15 to both sides. Yep. Positive 6. So we have the point. I don't know what I'm doing. Having a hard time. 0, 6, 2, 4, 6. So that also means we're going to have another point where? So 12, 6, right? So right there, connect the dots. It's cute.
Why is that at 12?
Because that's the other side of the axis of symmetry. Right? Is this 6? This is, yeah. That's the graph. It's good enough. Easy peasy. Times it. Barely. Okay. We're gonna do the beginning part because the beginning part is the only part that's different anyway. So we're gonna do the beginning part of this example right here, and then I'm gonna assign you some homework, and then I'm gonna kick you out. Sound good? Good.
Just real quick, when we did the green part and we did the added it to the other side, do you always multiply by a?
Yes. 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 Great. So we're going to write an equation and then graph, but we're probably not going to worry about graphing because y'all can do that later. Right? We're going to write the equation of a parabola that has these characteristics. Has a focus at 3, negative 4, and a vertex at 1, negative 4. So we need to write the equation. So how would we do that?
Okay, so we know focus is H and then K plus P, and then vertex is H.
Which direction is this parabola going to open? Nope. Nope. You're going to get there eventually. It is going to open to the right. Definitely going to open to the right.
How do we know this?
That's what I'm going to ask you. How do I know that? Looking at those numbers.
I have a question.
Something that's negative?
How do you know that?
Okay, because
What is the vertex?
Vertex is the point.
Yeah, the little top, bottom, left, right point. The farthest this point, right? Where is the focus? Inside the parabola or outside the parabola? Inside. So if we're starting at 1 and then we're pointing towards 3, we're going this way. Okay. So this is definite. So which standard form are we looking at?
Looking at the y minus k squared equals the horizontal one, yeah. I don't have to say it out loud. You have it memorized most likely.
Great. So let's get the parentheses parts because those are easy, right? That's just the vertex, right? So y plus 4 squared equals 4p times x minus 3. You tell me.
because it was -4 last time only because P was -1.
Because if we put a -4 in here, what happens?
Oh, then it's oh, wrong form, sorry.
Okay. Now, it would be very helpful to know what P is at this point, right?
P is 0.
P is 0, she says. There's no way that's right. P can't be 0.
Okay, so
Because you're looking at the other. You're looking at the wrong direction. Okay. How do we figure out what is the formula for P?
Y equals H minus B.
Y equals H minus P, except no, it's not that.
Is there like a set equation for that?
Yeah.
We can write it down.
Where?
Where is an equation that has P in it that goes with this? And we don't want the directrix one because we have the focus.
You want the focus one?
Yeah.
H, or for the horizontal one, H plus P and K. Because the one we wrote down has P in it and it has to do with focus.
That's right. That's good.
Okay, cool.
So we're going to be here, right? So let me tell you this in a different way. So maybe we've got vertex here, focus here. What do I need to know to get from here to here? This distance, right? So that's the distance I want to know, right? So what is that distance? And to get from here, to get from this guy to this guy is 2. So what is P? 2.
And it's only on the X, not Y.
Right. Yeah, because the focus is in line with the vertex, and we're opening to the right. So the vertex, whatever, it's the one that changes between the two, not the one that stays the same. So P is 2. So let's finish our equation.
And H is 3, because, no, it's not.
You're looking at the wrong one, but yeah, H is this, yes?
Yes. So,
Y plus 4 squared equals 8 times x minus 3.
easy money.
Easy, easy money.
That's done, right? That's the thing.
Oh, good. It does actually match the book. I was scared. It's like, what did I do wrong? I was looking at the totally wrong problem. Yeah, there's the equation. You would graph that and peace out, right? Speaking of peace out, homework. It is so flipping hot in here. I need to make sure that the thing is on right. I don't think it is.
Why is that a 3?
Why is it a 3? Oh, it should be a 1, right? Great, homework. I did this, I made the exact same mistake Garrett just made. I just made it a long time ago. Homework, page 428. Numbers. 2 through 24, no, lies. 2 through 34 evens. Actually, that's not really even true either. It's good thing that it's your homework is due on Tuesday because you have a lot. Here we go. 2 through 44 evens.
Army is so good at this thing.
That's really not like a lot for like 4 days. Just saying that's like chump change. Chump change.
What classes I have to do homework for?
When I was in high school, we would have twice that. I don't really want to hear it. 20 problems between a Tuesday and a Thursday is nothing. It really is nothing. Yes, you do have other classes. Welcome to high school. Time management. That's like one of the main skills we learn in high school. Well, one of the main skills we're supposed to learn.
That people learn?
Not really. I know I didn't. Not until much later, and even still I struggle with it.